Hello everyone. So I will be discussing about the today's Leetcode challenge, that is 1482, minimum number of days to make M buckets. So let's look at the problem. So here you can see that we have given an integer array, bloom days, an integer M and integer K, and we want to make M buckets. To make a bucket, you need to use K adjacent flowers of the garden from the garden. The garden consists of n flowers, and the ith flower will bloom in the bloom day of I, and then can be used in exactly one bouquet. Return the minimum number of days you need to wait to be able to make M bouquets from the garden. If it is impossible, then you have to return -1. So let's take the example. Consider bloom day as BD equals to 1, 1, 10, 3, 10, 2. M is 3 and K equals to 1. So it's what BD array implies that on for flower 1, first flower, it will bloom in 1 day. Similarly, second flower will bloom in 10th day basically, and the third flower will bloom in third day. Similarly, others. So let's look at on day 1 and denote the blooming flower by check mark. So we can see that on day 1, first flower can bloom because it can bloom in first day. Similarly, second flower will bloom in 10th day. So in day 1 it can't bloom. Similarly, third flower will not bloom. Then 10th, fourth flower, and lastly this flower will also not bloom. Consider day 2. This flower will bloom obviously. This will not bloom, this will not bloom, and this also, and this will bloom. Why? Because we are looking for day 2, and in day 2 this flower will bloom. It's given in the array, right? It's given in the array. Similarly, look at the day 3. This flower will bloom, this will not bloom, this will bloom. Why? Because we can see that the third flower can bloom in day 3, and we are looking for day 3, right? And in the second last flower this will not bloom because it will take 10 days, and this is already bloomed. So we can see that this flower is bloomed, this pack of flower is bloomed, and this flower is bloomed. And we have been given that for k equals to 1 we have to use k. What is k? Basically, k is, we have to make use of k adjacent flowers to make one bouquet. So here k is equals to 1, so we have to also look the adjacent flowers. So here we have one adjacent flowers, so we can make one bouquet, right? So one bouquet will be formed here. Similarly, other pack of flowers is 1, so here also one bouquet will be formed. Here also k is equals to 1 because there is one flower in adjacent, there is one adjacent flower, so here another pack of flowers can be collected to make another bouquets. So in all we have 3 bouquets which can be formed here on day 3. So it satisfies our criterion, that is m equals to 3. So we can say that answer is 3, and that's what it is given in the output. So what we can think of is, like, we are given for a particular day, let's say day equals to x, we have to find minimum day, minimum ones, such that it satisfies the criteria of m bouquets, such that each bouquet utilizes k adjacent flowers. What does it mean? Like, let's suppose k equals to 3 and m is 2. So this, so consider after xth day, the situation looks like this. So we can easily see that this pack of flowers can form one bouquet. Why? Because it satisfies the criteria of k adjacent flowers. K equals to 3, right? You have taken k equals to 3. Similarly, this pack of flowers can also can make a bouquet because here also k equals to 3. Similarly, this one. So we can for sure say that for xth day, this arrangement can be satisfied. This arrangement of flowers is okay for satisfying our criteria. So the answer will be X. Now, after looking at this, we tend to think like it is like looks like at particular xth day, let's say the criteria is not satisfied. Criteria is not satisfied. So similarly, for x plus 1th day, criteria is not satisfied. I'm just considering the number of days, right? Similarly, at particular day, let's say x plus pth day, the criteria is satisfied. Similarly, as we increase from now onwards the number of days, it will always satisfy our criteria, right? So we can think, so this pattern looks like a monotonic functions. Why? Because it looks like at this time, let's say there is x day, it satisfies, it doesn't satisfy the criteria. Similarly, here also doesn't satisfy the criteria. And at particular day, let's say yth day, it starts to satisfy the criteria. That is, it can form m bouquets with k consecutive and k adjacent flowers. So looking at this, I only can think of, we can think of binary search, right? In binary search in answer, because binary search applies on a predicate, applies on a monotonic predicate function. Now what does it mean? Monotonic function can either be increasing function or a decreasing function, and predicate implies true and false. So this function, let's say this is f of x. So this function set x is the number of days, and we have to minimize this x. So this function is either giving true or false, but at certain time it starts giving the truly values, right? So how we can apply this? So once we are sure that we can apply binary search, but binary search has certain search space. Search space basically implies the low and high values. Like in this range, our answer will exist, right? Let's look at the next page. So in binary search, we have low and high value. This is basically with context to our problem, it will be days, because this is what we are minimizing, right? So our search space will include these values, low and high. Now what is low and what is high? Low will be the minimum element in bloom day, right? Why? Because let's say look at the example. Here we have 1, 10, 3, 10, and 2. 1, 3, 10, and 2. So looking at this value, we are very sure that on first day itself this flower will bloom. We are very sure because this is the minimum value. So our answer might be this one as well. So we can take as low value as 1, and the maximum value is 10. So on day 10th all flowers will bloom, right? So our maximum number of days can be this 10. Once the search space is defined, we can apply the binary search. So let's look at the solution now. So this is the solution which I have implemented. Of course, I took longer time, but initially after reading a problem and after some time, like barely 5 to 10 minutes, I was able to get the idea like this problem will be solved using the binary search. So let's look at the problem in the editor. So what I have done is like we have a vector of bloom day and an m. So what basically is m? M is the number of bouquets and k is k number of adjacent flowers bloomed. Like consider k equals to 3, which I've already showed you. Like let's say x is the bloomed part. So there can be x in k equals to 3 times consecutive. Similarly, the dot represents non-bloomed flowers. Similarly, there is x consecutive ones. So here we have m equals to 2. Why? Because there are two such instances where the k there are three flowers which in consecutive present consecutively, right? So here I have taken low value, which I have discussed. Low value can be 10 to the power 9. You can take any maximum value, and high will be any minimum value, because high will be the maximum, so initializing with the minimum, right? So I have applied this for loop. For loop can go from for loop which I iterate on all the days, all the elements in the bloom day to find the maximum and the minimum days. Here, which let's remove this, and here I am applying the binary search on answer. Binary search on answer, and I am doing the mid. I'm finding the mid value using both the low and high on the search space. Now this is the interesting part. This day is satisfied. This is the monotonic function. Once we are doing half each time in the search space, that this mid is the number of days. Number of days. And in this value, we are finding whether this value satisfies or not. If this value satisfies, then this will be our answer. So I am storing high equals to mid. If prepared, that is, this value can be, these days can be used to prepare, then we will decrease the days. Basically, it will not decrease. We will keep this mid, right? Because this can be our answer. Because this can be our answer. Can be our answer. Now look at the is day satisfied part. Here we are looking like looking we are passing the number of days, and we are also passing the array and m and k. And for these number of days, we are looking consecutive ones. Consecutive ones, like we already had an example like 1, 10, and 3 and 2, right? So on day, let's say days equals to 1. Let's say days equals to 3. So this will bloom, this will not bloom. I'm representing x as bloomed flowers, right? So this will also bloom, and this will also bloom. So we can see that there are three such instances where flower can be collected k times consecutively to make m bouquets, right? So this code does exactly the same. It iterates in the B. This B is basically that array which was given in the question. And once we find that this element is satisfying the number of days, because less than equals to implies that, of course, if it satisfies this, then if the required days, which is less than the given days, then obviously it will bloom. And we iterate on it to count those consecutive ones, and basically if it satisfies this criteria, then it will return true, else false, and we keep counting it. Here we are looking for, here once we get those boundary conditions in the search space, that is low and high, then we will look for the low values. Why? Because we are finding the minimum days. If this low doesn't satisfy, then we will look for high, and this also doesn't satisfy, then we'll simply return -1. Why -1? Because it's given that if no days can satisfy, then return -1. So let's run this code. It is exactly the same code which I explained right now. And yes, it passes the test case. Let's submit as well. Indeed, it passes the test cases. Now, this question, such types of question are basically the binary search and answer. For practice, you can look the another problem like a problem I can remember like it's aggressive cows on a stodge. So you can try out this problem. This problem also uses the same logic like binary search and answer. So you can try this out. Similarly, there are many other problems in code courses you can find out. Thank you.